Solving linear systems by substitution. When solving linear systems by substitution, you use the ISSSCC method. I know this sounds like a mouthful, but it helps you remember what to do, what the steps are when you're solving systems of equations by substitution. So step number one is to isolate a positive variable from either of the equations. And the tip I want to give to you is to label your equations. So the first one I'm going to label as equation 1. The second one will be equation 2. So it says isolate a positive variable from either of the equations. It's already done for us in this one, so we actually don't have to do this step. So sometimes your step 1 will be done for you, and that is wonderful when it is. So then we can move on to the next step. Step number 2, substitute the newly rearranged equation into the other equation. And the tip is to write out your steps, so i.e. sub 1 into 2. So that's exactly what we're going to do. We're going to substitute equation 1 into equation 2. So the value of y, so y is equal to 5x plus 5 in example 1, or equation 1, and we're going to place this into the value for y. So I'm going to put it right here into the equation for the value for y. So this 5x plus 5 is going to be right there. I'm going to replace it into the y in my second equation. So what's it going to look like? It's going to look like this. 5x plus 5 is equal to negative 2x minus 2. So that's step 2, substitute. So isolate, substitute. So step 3 is to solve for the variable. So once we've substituted the equation into the other equation, you'll notice we only have one letter left, which is what we want. So now we can solve for the letter x. And we do that by using our skills from algebra, by moving all of our like terms to one side or all of your variables to one side and all of your constant to the other side, and then solving for that value for x. So that's what we're going to do here. So the first thing we want to do is we want to start by, and you can do multiple steps in one line of your solution, that's fine, or you can show step by step. I'm going to show you step by step for this one, just so you have that as a reference. So I'm going to start by moving my negative 2x to the other side. So I have 5x plus 5 is equal to negative 2x, but actually I'm going to do it the other way around. Okay. I'm going to start by moving my 5 over to the other side. That probably makes more sense. So 5x plus 5, and then to get rid of the 5 on the left-hand side, I'm going to subtract it from both sides. So negative 5 is equal to negative 2x minus 2 minus 5. So the 5's disappear from the left-hand side. So I have 5x is equal to negative 2x, and negative 2 subtract 5 is negative 7. So now I want to move my 2x over. So in order to move my 2x over, I need to add it to both sides. So 5x plus 2x is equal to negative 2x plus 2x minus 7. That way it eliminates it from the right-hand side. 5x plus 2x equals 7x, and that is equal to negative 7. The last step is to divide both sides by the coefficient in front of your letter. So divide both sides by 7. 7 divided by 7, I'm just going to draw an arrow here to show that I'm still doing my work. So 7 divided by 7 is 1, so x equals, and negative 7 divided by 7 is negative 1. So isolate, substitute, solve. Now what I want to do is substitute the value that I found right here. So my x equals negative 1. And I'm going to put it into one of my original equations. And that way I can solve for my y. And the tip that I have for this one is to choose the simpler one. So whatever one you think is going to be easier, do that one. So I'm going to put it into I'm going to put it into equation 1 because I only have positive values and I don't have to worry about any negative values. So right here I have, right, the 5x plus 5. I'm going to substitute x equals 3 x equals -1 into my equation 1. So sub x equals -1 into equation 1. So equation 1 was y equals 5x plus 5. So y equals 5 times -1 plus 5. Y equals 5 times -1 is -5 plus 5, and y equals 0. Okay, so now I have a value for x and I have a value for y. So this ideally would tell me what the coordinate would be if I was correct. So, but in order to do that, just like you did in graphing, we're going to do the left side, right side check for both equations. So I'm going to just divide this up into 2. And I'm going to do it a little bit differently in an effort to save room. So know that you can do that. So my equation for the first one is y equals 5x plus 5. My y is 0. My x is -1. So I'm not going to move anything to other sides. I'm just going to solve it all the way down. So 0 is equal to 5 times -1 is -5 plus 5. 0 equals 0. So far so good on that side. Left side equals right side. That's wonderful. My second equation is y equals -2 take away 2. So my x was -1 and my y is 0. So 0 is equal to -2 times -1, subtract 2. 0 is equal to -2 times -1 is +2. So take away 2. 0 equals 0. So left side equals right side, which is what I wanted. So isolate, substitute, solve, substitute, check, and our last step is conclude. So now we can say with certain, so therefore the point of intersection is -1, 0. So isolate, substitute, solve, substitute, check, conclude. So let's do those same steps for example 2. So we're going to start by labeling your equations 1 and 2. Step number 1, isolate a positive variable from either of the equations. Look at that, it's already done for my y, my first equation. That's excellent. So I'm going to substitute my x minus 1 into my y in my second equation. This should be a y. So I'm going to substitute in that right there. Okay, so step number 2, substitute. So we're going to sub 1 into 2. So I have 3x minus 4 times -x minus 1 minus 11 equals 0. So I've substituted that in. So substitute is my second step. Step 3 is to solve. So now we're going to solve for x in this case because that's the only letter that's left. So I have 3x, and I'm going to use the distributive property now. So -4 times -x is +4x. -4 times -1 is +4. And then minus 11 equals 0. Let's collect our like terms. 3x plus 4x is 7x. 4 take away 11 is -7 equals 0. I'm going to move my 7 to the other side. So 7x equals 0 plus 7, or 7x is equal to 7. Divide both sides by the coefficient in front of your variable. 7 divided by 7 is 1x, or x, and 7 divided by 7 is 1. So x equals 1. So now I'm going to take this equation, I'm going to plug it back into whichever equation up here, my original equations, I think it's easier. And I think number 1 is going to be easier, so I'm going to substitute x equals 1 into equation 1. So sub x equals 1 into equation 1. So equation 1 again was negative x take away 1. So y is equal to negative 1 take away 1, which is negative 2. So now I have a value for my y. Let's do our left side, right side checks to verify my answers are correct. Again, I'm going to just divide this into 2 sections. And again, I'm going to do it slightly different than we've done before in an effort to save some room. So equation 1 is y equals negative x minus 1. My value for x is 1. My value for y is negative 2. So negative 2 is equal to negative 1 take away 1. Negative 2 is equal to negative 2. Left side equals right side. That's excellent. Okay, up here, my equation 2, 3x minus 4y minus 11 equals 0. So 3x minus 4y minus 11 equals 0. Okay, so 3 times 1, take away 4 times negative 2, negative 11 equals 0. 3 times 1 is 3. Negative 4 times negative 2 is negative 8. Positive 8. Take away 11 equals 0. 3 plus 8 is 11. Take away 11 equals 0. 11 take away 11 is 0. Look at that. Left side equals right side. That's what we wanted to see. So we're not moving anything over when we're doing our left side, right side checks. We're just going straight down just to verify that they do equal the same thing. So now that we have identified or verified that our left side, right side checks are the same, we can say with confidence or conclusion, therefore, the point of intersection is 1, negative 2. So those are some of the easier substitution equations. I know they all seem a little tricky at first, but those are some of the easier ones. We're going to take a look at some that are maybe slightly harder because we have to do step 1. We have to isolate one of these equations. And remember, we want a positive variable. So it's important for you to think about, well, which one, well, first we're going to start by labeling our equations, 1 and 2. And then we have to think about, are there any coefficients that are 1? Well, yeah, and right in front of our y. So this becomes the one that we're going to isolate for because there is no other number other than a 1 in front of your letter. So we're going to isolate, and we want a positive variable, remember that. So if it's already positive on this side, you move everything else over. But if it's negative on this side, you want to move it to the other side. So we're going to move our negative y over. So we have 4x is equal to y plus 5. So I've just moved my y over to make it a positive y. And now I'm going to move over my positive 5 to this side to isolate for y. So I have 4x, the opposite of adding is subtracting 5, is equal to y. So I can keep it like this, or if you wanted to, you could write it like this, y equals 4x minus 5. If you like to have your variable on the isolated variable on the left-hand side, you can do that. These mean the same thing. You can write whatever way you want. So because we have rearranged equation 2, we're going to substitute this expression for y into the y for equation number 1. Okay, so we're going to substitute 2 into 1. So I know before we substituted 1 into 2, but because we rearranged equation 2, now we have to substitute 2 into 1. So we're going to do that right here. We're going to substitute the value, so 3x plus 2, and then our y, which is 4x minus 5, is equal to 12. So that's step 2. Isolate and then substitute. Now we can solve. We want to do that by applying the distributive property first to get rid of the brackets. So we have 3x plus 2. Sorry, we don't have that plus 2 anymore. 2 times 4x is 8x. 2 times negative 5 is negative 10. And that's equal to 12. 3x plus 8x is 11x. Take away 10 is equal to 12. We're going to add 10 to both sides to get rid of it from the left-hand side. So 11x is equal to 12 plus 10. So we're moving that over. So let's simplify this. 11x is equal to 22. Now we need to divide both sides by the coefficient in front of the x. 11 divided by 11 is 1. So x. And 22 divided by 11 is 2. So now we have a value of x equals 2. So we've done our isolate, we've done our substitute, we've done our solve. We're at step 4, which is the second substitute. So we're going to substitute x equals 2 back into whatever equation we think is easiest. So let's try equation 2, okay? Because there's only one, there's not as many numbers to multiply by. And the values are smaller, right? We'd have a 12, like a 5 instead of a 12. You can substitute really into either one, but try to put it back into the one that's a little bit easier. So we're going to substitute x equals 2 into equation 1. So equation 1, as we said, into equation 2 we said. All right, and equation 2 is 4x minus y equals 5. And now we're going to solve for our y. So 4 times 2 minus y is equal to 5. 4 times 2 is 8 minus y is equal to 5. And then I can move my y over to the other side. So 8 is equal to y plus 5. So I can move that over. Now I can move my 5 over. So I'm just going to write it up here. So I have 8 minus 5 is equal to y, and 8 minus 5 is 3, so 3 equals y. Or you could write it as y equals 3. They both mean the same thing, whichever way works for you. So now we have a value for x, and we have a value for y. So now we need to solve, or to check our answer, so that's step 5, check. Doing a left side, right side check with our original equation. So 3x plus 2y equals 12. Is example 1. 3x plus, what did I say again? Yeah, 2y equals 12. All right, so 3 times 2 plus 2 times 3 is equal to 12. 3 times 2 is 6, plus 2 times 3 is 6. 6 plus 6 is 12. 12 equals 12. Left side equals right side. We're off to a good start. All right, second equation. 4x minus y is equal to 5. 4 times 2 minus 3 is equal to 5. 4 times 2 is 8. Take away 3. 8 take away 3 is 5. 5 equals 5. Left side equals right side. That's what we want. So now we can say for certain, therefore, the point of intersection is 2, 3. Last example. Label your equations 1 and 2. And we want to isolate. So we want to isolate a positive variable from either of the equations. So which one has a coefficient of 1? We have the x in example equation 1. So we're going to isolate for x. So we're going to move everything that's not an x to the other side. So I have x equals, in this case, we're going to have a positive 2y plus 2. So now I'm going to substitute this value of x into the value of x in equation 2. So sub 1 into 2. And sometimes people relabel this, so they label this as 3 and then they substitute 3 into 2. Or you can just know that you've rearranged 1 and substitute 1 into 2. I'm happy with that. Okay, so starting with equation 2, so 5, and instead of x, I'm putting 2y plus 2, and then take away 3y is equal to negative 11. So now I only have one letter, which is my y, and I can solve for my y. So isolate, substitute, now we solve. Remember, we solve using our distributive property in this example first to take away our brackets. So 5 times 2y is 10y. 5 times 2 is 10. And then minus 3y and equals to negative 11. And we want to combine our like terms on the left-hand side. 10y take away 3y is 7y. And we're going to move over our 10 at the same time. So we're going to move this over. So the opposite of adding 10 is subtracting 10. So it's negative 11 take away 10. So 7y is equal to negative 21. Now we divide both sides by 7, the coefficient in front of your y. 7 divided by 7 is 1, so 1y, and negative 21 divided by 7 is negative 3. So now I have a value for x and for y. Actually, no, I don't. I just have a value for y yet. I got ahead of myself. So now I have a value for y, and I'm going to substitute it back into one of my original equations. Whichever one I think is easier, let's go with 1. So substitute y equals negative 3 into 1. So equation 1 is x minus 2y equals 2. So x minus 2 times negative 3 is equal to 2. X negative 2 times negative 3 is positive 6 equals to 2. Let's move this 6 over. So it becomes a negative. So x is equal to 2 minus 6. So x is equal to negative 4. Now I have a value for x and y. So now I need to do my left side, right side check. Equation 1 is x minus 2y is equal to 2. X is negative 4 minus 2 times negative 3. Equals to 2. Negative 4, negative 2 times negative 3 is positive 6. That equals 2. Negative 4 plus 6 is 2, equals 2. Left side equals right side. Now I need to do the same thing for equation 2. Equation 2 is 5x minus 3y equals negative 11. My value for x is negative 4. My value for y is negative 3. All right, let's solve this. 5 times negative 4 is negative 20. Negative 3 times negative 3 is positive 9. Negative 20 plus 9 is negative 11. Left side equals right side. Excellent. Now we can conclude with certainty. Therefore, our point of intersection is negative 4, negative 3. So if you follow the ISSSCC method for substitution, you will be on a good start and be very successful in solving for your systems of equations by substitution. So isolate, substitute, solve, substitute, check, conclude.